Hey everybody, this is Michael Parent with Michael Parent Consulting Services. Today what I wanted to do is have just one final conversation about measurement systems and measurement system analysis. Over the past several videos, we've introduced what measurement systems are and why they mattered. We introduced two types of MSAs, or measurement system analyses, and we walked you through how to conduct both of those. So today what I want to do is just kind of summarize everything we talked about and then give you the rest of that case. The very first video that we did, I showed you a case of a tire balancer, and I want to show you what we were able to accomplish through a measurement system analysis. So let's begin. As we mentioned, measurement systems are our entire method of taking a measurement for either a product or a process. We've used when I step on a bathroom scale, it's not just the scale itself, it's how I step on it. It's making sure that it's tiered at 0, calibrated beforehand, and that I'm taking a reading at some point, and all of that is the measurement system. We care about this because if our measurement system is not good, or if it's really variable relative to the measurements we're taking, we can make really bad decisions, or we can have false confidence in the things that we think we know, even though we don't, because there's so much error, there's so much variation in our measurement system. We talked about what this looks like in terms of kind of some high-level statistical concepts, right? Here's my process behavior. Here's my product. It's going to have different, depending on between products, I'm going to have different weights and measurements and all these things, and that's fine and that's great. We want to check to make sure it's in tolerance, but what we don't want to do is introduce a bunch of variation from the measurement. If we don't have a good measurement system, we can't protect our customer from projecting or passing these products onto them if they're not good. So this big normal curve, this big variation curve, is what we see, report, and make decisions on. And the goal of MSA, a measurement system analysis, is essentially just to validate, to make sure that our measurement systems are in fact good, and that they're reliable and that we can trust them. And if not, we want to improve that system. And that in and of itself is a good continuous improvement project, as I'll show you at the end with that case. We then talked about two different types of measurement system analyses. The tolerance, the one that you use tolerance in numbers with, we call it a gauge R&R. Remember that R&R stands for repeatability and reproducibility. And then we also have kind of this pass-fail mechanism, the attributes. Is this good, is this bad? We talked about what those looked like. Repeatability is agreement within operator. So if this operator looks at each guitar twice, is he agreeing with himself? And if not, there's some error there, because one time he's correct and one time he's incorrect. And then reproducibility. Is there agreement between operators? Is there some sort of bias where operator 1 is more of a stickler or is more stringent than operator 2, and for that matter, he's rejecting more guitars because of it? So we see by measuring both of these things, it's very, very important for us to get an idea of our own reliability and repeatability within the measurement system. Repeatability and reproducibility for our measurement system. And then we talked about our actual tests for the repeatability and reproducibility, right? We first looked at the gauge R&R, and we showed kind of some of those charts. The most important one is this one on the upper right. We want to make sure that the total gauge R&R, which is the sum of the repeatability and the reproducibility, is less than 20%. That means almost all of the variation that we actually observe is in our process or our product, which is a very, very good thing. So we use kind of this litmus test. If it's less than 20%, if our total gauge R&R is less than 20% of all variation, that's great, that's acceptable. 20 to 30, marginal. And if it's greater than 30%, we can't say with any confidence that we're actually measuring things correctly. Imagine if you weighed 200 pounds and your scale showed anywhere from 260 to 140 pounds. You'd probably throw out the scale. You'd get a different scale, right? So that's what we're talking about when we say unacceptable. So we also looked at some other factors. We looked at kind of the repeatability here, the average and reproducibility, right, is are they agreeing with themselves? Are they agreeing with each other? And then over here, are they agreeing with themselves? Then we looked at the attribute R&R, and we used a different kind of litmus test here. Again, where we're saying, look, if it's 90%, I don't like these colors. I'm gonna change them right now. If just 10%, right, if 10% of the variation is in the measurement system, that's fine. So if 90% is in agreement, that's great. If it's 80% or 20% error, that's marginal. And if it's greater than 20%, it's unacceptable. So again, because we're using attributes rather than like actual real numbers, we have to be a little bit more stringent, because there's not as much precision, there's not as much resolution into these sorts of measurements. So therefore, we just want to be a little bit more careful. So that, in a nutshell, is everything we talked about with MSA's measurement system analyses. And what I wanted to do now is finish up with that case study. So you may recall this case study was that there was a tire balancer in a dealership. And what they have to do is they have to make sure that the tire is uniform, so that it's not shaking the car around. And they use this measurement of 20 ounces. If there's some sort of force that's greater than 20 ounces on the tire, then it has to be replaced, and that costs the customer money. And if we're having a bunch of false positives where we're saying you have to reject it but you actually don't, we're not delivering good customer value to our customers, and they're going to figure it out and they're going to go somewhere else. So we looked at the repeatability and reproducibility of this. Really, the repeatability of the tire machine is what we actually did. We looked at 3 different tires and had 3 trials for each of them, and we came up with this distribution. We had a standard deviation of 1.84 ounces, and what that means is that a tire with a balance of 18 ounces. So if I have a tire that's in spec, it has 18 ounces, that's going to have a false positive. It's going to be rejected for being greater than 20 ounces 15% of the time. So this here, we would say is really not good. All of our variation is really coming from, or a lot of our variation is coming from the measurement system itself, which is not acceptable. And therefore, we went into a measurement system analysis improvement project, and we called the vendor, the manufacturer of our balancer, and we asked them how to get better measurements. And they actually knew this was a problem for them, and they went and fixed it. And one of the biggest things that they fixed is just this little plate here, this face plate. It was here, and there was kind of 2 points of contact on that tire rim. And what they told us is that if you flip it around and you have more points of contact, you have a larger point of contact for this, for the rim of the tire, then what you're actually going to get is you're going to get less wobbling, and you're going to have a better measurement for the tire. And as we did that, what we saw is that we dropped the variation of our measurement system by 72%. Which is incredible. It was 1.84 ounces. Now it's 0.51 ounces. So a 72% reduction. And what that means for the customers is now there's a 0.004 of a percent chance that if we have a tire that is 18 ounces, it will register as 20, which is a huge improvement. That's almost impossible to imagine, right? That there's really no chance now that we're going to give that customer a false positive, whereas before it was 15 out of every 100 tires, right? So a huge improvement that we've delivered value to our customers simply by improving the measurement system. So I hope you enjoyed this. Please like and share, and contact me if you have any questions about MSAs or how to do anything